All right. Hey guys, welcome back to another Wizards Lizard 2 game development live stream. I'm Jeff from Lost Decade Games. Thanks for joining. And here we are. We're going to do some more work on a Wizards Lizard Part 2. So thanks for coming, as always. Hello, Joe. Thanks for coming by. It's always good to see you. I guess we'll just kind of talk about what's been going on. First is a lot of art from Matt. We saw some of it last week. He's been pumping out all kinds of really cool environment stuff for the house environment right now. And I'm not going to do too much with that stuff right now on the stream, but that is one of the things we've been working on. All kinds of new props, bookshelves, buckets, cauldrons, wall lamps, barrels, explosive boxes, what have you. So all kinds of cool stuff going on there. So that's fun. Let's see. Let's take a look at what we're looking at right now. We got. I did a little bit more work on the physics stuff. I think last stream I was kind of working on the interaction between physics, velocity of stuff, and things that blow up. And I kind of got that in a better place than I had it before. So I can take a look at that if I can find an explosive barrel somewhere. We'll see. Hey, there's one. Anyways, yeah, so I can pick these things up, these little balls, and now you can kind of nudge around these, the boxes, the crates. You can move them around. Not super happy with the friction on those yet, but you can see that it doesn't blow up like when I just touch it. And if I were to kind of kick this ball into it, it won't blow up either. So there's like a nice threshold velocity-wise where if I spit the ball with some velocity, it'll blow up, and then it'll kind of recoil back. So solve that problem from last week. This week, though, I'm going to work on some gizmos, which are the term I'm using for, or mechanisms, I think I called them on an earlier stream. But these are going to be like toggle buttons, switches, things that kind of go up and down to block your path, these wall blocks right here. I took a pass at these on an earlier stream, well, many weeks ago. And I wasn't super happy with them at that point, and I've been thinking a lot about how to make those better. And so we're going to see if we can't do that. So the first thing we're going to do today is kind of build out the wall blocks first. Even though I had a previous version of them done, I don't love how I implemented them, so we're going to take another pass at it. So the first thing we're going to do is we're going to jump into our just generic scene, which has just got Raga, run around doing nothing, and then we'll start building these guys. So we're going to find our gizmos, and we've got the two sprites, the up and the down version, and so this will be a block that will kind of raise and lower. And the reason I want to take another pass at this is because the original one, it did it in a more Unity-centric way, which sounds like a good thing, but it's rather difficult for procedural generation. And so what I did was I have this prefab here. I think they're in objects right now. That actually work, these wall block toggles. The problem is, though, that right now they have these array of buttons that toggle them. So you could drag one of these guys here, or not. Oh, right, because I have to be in the scene. I could drag one of these guys here, and then I could also drag one of these guys here, which is a button. And then I could say, this pressure plate is toggled by, this button. Well, I'd have to give this a size first of, 1 is fine. And then I could, drag the pressure plate. No. There we go. And so I could basically say that this button controls this block. Oh, except this doesn't collide right now. let's fix that real quick. Is this a trigger? Yes, it is. Anyways, you can see it kind of goes up and down, which is, it's all fine and well. This thing should actually be solid. I've been doing a lot of messing around with the collision stuff lately, so now there you go. And then so if I hit this button, well, let's put something else in here. How about let's see if this works. Let's see if this just works the way I hope it works. Let's put that there. Yay! Now I can walk through it. Anyways, that stuff all works pretty well, but the problem is that it's not super easy to hook these things up, because you either have to, one, drag it into the Unity interface and say, hey, the buttons for this wall are these buttons here, which in a statically composed scene, that would actually work really well. But since we're procedurally generating everything, we're not going to be able to just drag and drop components onto each other like that, because these buttons are going to be generated dynamically at runtime, and so are the walls. And that's not going to work. So the way that I then solved that problem was I have, I think, wall block, button wall. There's a method that you can actually call called link button. And what that'll be able to do is that during the generation, you can actually call link button procedurally to link a button to a wall. The problem with that, though, is it kind of necessitates a lot of kind of convoluted code, because essentially what has to happen is that you need to kind of place the buttons and the walls in tandem, and like they have to know about each other in terms of procedural generation. And in some senses that they should, but it's a little more rigid than I like. And one of the things I was thinking about was that it's probably possible to dynamically look up things with like a given value. So for example, we could create a wall block and we could just give it some kind of arbitrary identifier like red door or blue or A or B or 7, or it really doesn't matter. It could just be any kind of random string that we want it to be. And then we can generate buttons that then affect any entities in the level that it would find with those with that specific property. So that's what we're going to try and do. We're going to try to take another stab at this with that in mind, because I think that that'll be a lot more easy. Because even though this stuff all works fine, it took a little bit of work to make it fine, and it's still not really in the place I want it to be. So as we mentioned on LostCast a lot, the first time we do anything, it probably sucks. And so this is going to be Gizmos 2.0. And we will see what we can come up with. Also, I have a bot now in the Twitch chat, which is pretty cool. So it's going to talk at you. It's going to spam some LDG related links to our Twitter feed, to LostCast, to our YouTube channel, and all that kind of stuff, because cross-pollination of all the LDG goodness is a good thing. Excuse me. Anywho, let's get to it now, for real this time. So the first thing we're going to do is we're going to create some of these prefabs from scratch, the gizmos. It looks like Matt actually just pushed some new graphics, so that's always fun. Let's grab those real quick. Nope. Thought that's what he said. I just pushed new wall blocks. No, you did not. You were a dirty liar, Matt Hackett. So anyways, we've got these wall blocks, and what we're going to do is we'll probably just start with this guy right here. And the first thing we need to do is we need to make it collidable, because if it's not blocking the player's path, then it's basically useless. So actually, the very first thing we're going to do is make sure that it renders correctly at above and below the player. So it does. That's great. Yay. I think what happens with Matt is that he just says git commit and then he doesn't read the output. And then he just assumes that it works because he sees words on the screen. And so he assumes that therefore nothing bad must have happened. So I'm going to add a I'm going to add a box collider to this guy actually because I think we're going to want this thing to be as large as a tile, as one tile. So we're going to make it one tile large, one tile big. And then, because I don't want, if several of these things were in a row, for example, like we don't want them to be, I guess, that we don't want any space where the player could, squeeze through them. So we want them to actually line up correctly. So I guess that's fine for now. Maybe we'll make another. Well, let's not make another one yet. Oh, now it's pushed for real apparently. Let's see if that's true. And yeah, oh, we got some new explosive crates as well. So let's see. Oh, I'm guessing these actually went to a different location. So let's delete that real quick. I've been trying to organize stuff a little bit. So yeah, there they are. Wall block down, wall block up. Okay, great. So what I'll do here is I will actually just delete these guys, the old ones. Matt and I were talking today about how they actually kind of read better as square. Yeah, the GitHub for Windows GUI is not bad. So, and Tower. I've never actually used Tower, but I've seen a lot of good things about it. And welcome to Salmon Moose. Thanks for dropping by. Anyway, so what we're going to do is we're going to grab this guy. Oops. Actually, first I need to set the sprite settings. Again, pixels per unit is 64 because that's our tile size, so everything's kind of relative to that. These guys I'm actually going to leave as single sprites, I think, because I want to make sure that they anchor correctly, and the easiest way to do that is just to let it default to the center. I think, yeah. So that's probably fine. So we'll just do that, and then we'll do the same thing on this other version, 64. Apply that, and then we'll start this again. We'll take this wall block, and then we'll add the box collider to it, or first we'll add the depth, sprite depth, and make it a tall object, and then add component box collider 2D, and make that one tile large. We actually probably do want to change the anchor point in this sprite, so we're going to change it to be the bottom. No. That is not correct. We want it to be center by default. So we really just kind of want it to be a little bit below center, actually. Guess what we can do, either that or we can just modify the, maybe we'll just modify the collision, the box collider. Yeah, so let's do a custom on this, and then we'll put the anchor point about that, because we kind of want it to sit a little bit above. We don't want like smack dab in the middle of the actual sprite. And then we'll just modify this box collider to be, we'll reset that, and then we'll make it one tile. And then we actually kind of want this to be in the center. Right about there. Let's see, I love the command line, but I'm a Linux guy, so PowerShell command breaks my heart. Yeah. I agree with you, Salmon. I really like the uh, Linux and OS X terminal, and using Commander and things like that are just they're really tough. So um, my wife is making faces at me. She's almost as bad as the cats in terms of interrupting the stream. No, I'm just kidding. Uh, yeah, interesting. I could use Mac as well, obviously, because the unit is on Mac, but I don't. Anyways, I'm getting distracted here with this box collider thing, so I think what I'm going to do is what I really want is I want to make sure that the box collider 2D is not offset at all, and it's exactly one tile wide. There we go. So that's what we're going to do. And we're going to make sure this is on the solid layer, which is our layer where things collide with each other. Solid thing, so we got that. And that looks good. You can kind of hit it from all angles, so that's good. And let's see. And I think that for this, we'll make it static. I try to make things static when possible, because I don't think this thing is going to be going anywhere. You're not going to be able to push it, etc., etc. So that's good. The next thing we're going to do is we're going to give it a couple things. One is that we want to toggle it based on something. And we kind of want to make this generic at first because we want to have this thing be able to be toggled many different ways. You can imagine there's like pressure plates or there's switches or who knows, or there could be multiple switches, all kinds of stuff that we would want to do. So what we're going to do is we're actually going to create this prefab in kind of a dumb way where it just has a switch that we can programmatically flip on or off in order to raise or lower it. So, wow, cats. They decided they were going to have a battle right here. So we'll say, we're going to call this thing wall block. And what we're going to do is we're going to create a new script. Scripts. New C# script. I think I already have something called the wall block, though, don't I? Let's see. Oh, button wall, yeah. So when I originally made this thing, it was a derivative of the button class, because I kind of figured, like, hey, this is like a two-state thing as well, but I kind of feel like that's not the right way to go. I think it's a little bit of inheritance abuse, and so I'm going to do it a little differently this time. Hey, Dan Nagel, welcome. That's right, it's Monday Night Game Dev. It's kind of like Monday Night Football, but way more awesome. And then I'm going to rename that class to be in line with what it's actually called in the file system. Wait, wall button. That's what I wanted. Wall block. There we go. Okay. We're making progress here, I promise. Okay. So the first thing we're going to want to do is we're going to want to have a sprite object, which is going to be the, we'll call it inactive sprite. And this is going to be the version of the block that we're going to display when it's not active. I'm guessing Salmon is not in the same time zone because it's apparently Tuesday morning for him. That sounds like Australia, perhaps. Europe. No, no. Are you sure? Tuesday morning? Melissa, my wife, says Europe. I'm going to say Australia. We'll see who's correct. Huh?
8 hours.
8 hours? Maybe. I don't know. No, 8 hours would be like 2 a.m. Yeah. We'll see. We'll see. Anyways, so what we're going to do here is also create a method here called toggle. And that's just going to change the state. And so for now, we're going to just keep it like turning it off, and then we'll expand it as we go. And so we're going to say, oh, we also need a reference to the sprite renderer. So we're going to create a sprite renderer. Well, Actually, that's not true. The way that I've been liking to do this stuff is a concept we kind of had back in a Wizard's Lizard 1, which was that we kind of separated the mechanical implementation of something from its visual implementation. And that worked really well, and it keeps things kind of clean and easy to deal with. So what I'm going to do here is actually rename this to wall block pawn. And then the wall block pawn is actually what's going to be handling the visual aspects of this thing. And we can kind of develop them side by side. So this is the thing that's actually going to have the inactive sprite, or sorry, it's going to be sprite, and we'll call it inactive sprite. And then it's also going to have a reference to sprite renderer, which is the Unity component that controls the sprite rendering, funnily enough. Right? I know, doesn't make any sense, but hey. And then we'll just create a reference to that. So we'll say get component, sprite renderer, and then essentially what we're going to do is also have a reference to the wall block class here, or component rather. And we'll do the same thing, wall block equals get component wall block. Something else I learned how to do in Unity, wall block pawn, is that you can actually say require component. It's kind of like this meta directive. Require component, and I think it's going to be type of wall block. Anyways, what this is going to do is that if we add this wall block pawn component to a entity, it'll automatically add the wall block, and so we can make sure that we have our dependencies all lined up. Ah, yes. Radelaide? So it is Australia. South Australia. Is that not Adelaide? I guess it's a different... I've never heard of that city. Salmon Moose is not enjoying the future, apparently, so we're all doomed. Yeah. And Joe correctly points out that we are living in the past in so many ways. Anyway, so now that we got these components, essentially what we're going to do here is we're going to listen to an event that I haven't made yet, but I will make it right now. It's going to be public delegate void. We're going to call this wall block. We'll call this deactivate. And this is going to be an event that we're going to raise when it gets deactivated. So wall block deactivate, and then it's going to call on deactivate is what we're going to call it now. And then we're actually going to create a public void deactivate is going to be the method name, and then really what we're going to do is have this public bool, which is going to be active, is going to start out true for now. And then this will just say active is equal to false, and then we'll say if on deactivate is not null, we're going to go ahead and say call on deactivate. And then here, this is a little more convoluted than you can make it otherwise, but again, I like that it keeps a little bit separate. On deactivate plus equals on wall block deactivate. No, we don't need parentheses there. And then we just need a function here called on wall block deactivate, which is just going to handle that stuff. And in here we're going to say sprite renderer dot sprite is equal to inactive sprite. Yes. Great. So easy peasy so far. Then we're going to go back in Unity and we're going to grab this guy. and we're going to add this wall block pawn, and you see it added the wall block script by default, and we also have the inactive sprite here, which we're going to fill with this guy. So this is our 64, so what we're going to do is we're going to grab that guy and just dump him right there. So we got wall block down as the inactive sprite. And now what we can do is just for testing purposes, we can say public on collision enter 2D. And this is a function, whoops, I'm going to need a return value there, a void. But this function gets called when two things collide. It also needs a collision 2D parameter, which we're not really going to use. We're just going to call deactivate right away, just to make sure. Dan, yeah, you can always go back and watch all the rest of the episodes. I don't know, that would probably take a lot of time. If you guys have any questions about what I'm doing, I will be happy to talk about it, because, you know, I love to talk. Joe's got it all summarized for you guys. Unity. There you go. I just pressed the Unity Make Game button and everything just kind of worked. Anyways, hopefully what we should be seeing here now is that when I collide this block, yep, it goes down. Hooray! So, you know, the events are working and all this stuff is all working. So that's good. Matt has nightmares about missing class arguments, apparently. So the next thing we want to do is when we deactivate it, or when it becomes inactive, we want to make sure that it is no longer collidable. So I think this is actually where I'm going to have to return to the handy dandy internet, and it's going to be Unity disable component. I forgot what the syntax for that was. I think it's just enabled. Oh, I don't want a video. Let's see. No? Oh no. Actually, you know what I can do is I can just look it up. Because I did this previously, so I should just look at my own code. In the button wall. There we go. Get component collider 2D dot enabled. Yeah. The internet is not having a happy day, apparently. So anyways, this, after we set this stuff to inactive, what we need to do is we'll say get component, and then we'll say collider 2D, which, as you remember, is our box collider. Dot enabled is equal to false for now. I might move that to a shared thing. Shared function later, but we'll see. Hooray! The other thing I want to do is, and I think I'm doing it here too, update components. And I'm guessing this happens with an actual button. Is that it also sets the sorting layer appropriately. So what we're going to do is we'll also have a, that would be in our pawn, which is going to take care of the rendering. So we'll say public, what is that, a string? Yeah. Public string, and we'll call that inactive sorting layer. And what we're going to do here is we're going to set this to, I think it's called flat objects, yes. Flat objects. So essentially what we're doing here is we're changing the sorting layer. So this sprite renderer component controls several things. One, what it looks like, and two, how it gets ordered in the draw phase. And so there's a couple things going on here. One is that there's a layer called tall objects, and that gets sorted above anything that's a flat object. So flat objects would be like rugs or blood splatters or anything that's really just going to be like flat on the floor. In addition to that, I have this depth component, which then automatically sets the order and layer to be based on the Y value of the sprite. So you can actually see that in action here. The wall block, if you look at it, has an order and layer of 29. Raga has an order and layer of 10. And if we move Raga around, you can see that change from 109 to negative, etc., etc., etc. So that's how here Raga is above the button, and then here he's below it. But since this button is now on the floor, like that looks really weird, right? Like he's just kind of under this button. That doesn't make any sense. Let's see. Hey, welcome, Rye Guy Davis. Thanks for joining. I've always heard every person that I've known from Australia has always complained about bad internet. I think it's just the infrastructure cables going across the ocean must be bad or something. But that's true, yeah. Amazon does own Twitch, so they really have no excuse for bad infrastructure at this point. Excuse me. So anyways, what we want to do is not only do we want to set the sprite here, but we also want to say sprite renderer something. It's going to be sorting layer name, right? Dot sorting layer name is equal to inactive sorting layer. There's cats climbing all over the place. Wow, cats flying all over the place. You can talk about the stream. That's fine, or the game, whatever's interesting. Hopefully the game is more interesting. If the stream is more interesting than, or the streaming service, then I'm doing a bad job, I guess. Anyways, as you can see now, like this just works. So now, once it's toggled, at first he's behind it, and then it toggles, and now he's above it. So we got that sorting stuff fixed. Oh, those weren't really cat noises. That was my wife ejecting the cat from the countertop where he wanted to be, and we don't want him to be because he's trying to eat stuff. So now we have that. The basic pieces work, right? So that's good. We got our kind of visual stuff here on the left, and then we've got our actual kind of mechanical stuff on the right. So the mechanical stuff is concerned with things like whether or not it's actually enabled or collidable. I think that we could also, well, yeah, I could require a box collider here, but I'm not gonna, because I guess right, cats falling everywhere. Yeah. So anyways, the next step is now to figure out how we want to link up these buttons. Or actually, first let's make the next button, the new buttons. Although we could probably just use the old ones, because we already have some buttons that already work, and they're pretty generic. Yeah, so the visibility modifiers work very similarly. You've got private, protected, public, and you've got all the same stuff. I don't know if C# or C++ has stuff like virtual and abstract and things like that, but I think it's probably closer to Java in that sense, although I don't know all that much about Java, to be completely honest. But it does have all kinds of stuff, so like, overrides and things like that. And actually I use that a little bit here. Like here, this is a protected virtual function right here, where protected means that the subclasses can also access it, and virtual means that it can be overridden by the subclass. So anyways, we have this pressure plate right here, and it's got some stuff. We just used it a few minutes ago to kind of talk about the other button, the first button. I need to probably make another layer for these things called gizmos or something, but this works for now. anyways, the way this is working right now is that the button actually has a state change event where it will, you know, call up to any listeners that the state has changed. I think in this case, though, what we're going to do for now is try and find everything in the level. Like, I kind of want to put the responsibility onto the button itself to look for things in the level that need toggling. And so what I'm going to do, and I think this is possible, but I'm going to find out very quick, is we're going to say find objects with component. Find objects of type. I think that's what I wanted, yes. Find objects of type. So hinge joint and hinges. This is not going to be super fast, obviously, but this isn't something that's going to be happening every frame. So I think it's okay. So we're not going to worry about optimization on this particular thing right away. So what we're going to do is, let's see, on activate and deactivate, so set state is false. This is where it actually creates this. And here's, I think, where I want to basically go through and I want to find, so find all the objects that have a component that I can toggle. In this case, the wall block. So I think what I'm going to do, I'm actually kind of surprised that this is on object and not game object, because game object.find is a thing that I use a lot, not object.find. So really, game object not match? Oh, might want to spell it correctly, huh? So game object, let's see, find objects with tag, find with tag, interesting. You probably want a game object list so you can assign toggleable items to specific buttons. I actually did. I created a, sorry, Dan Nagel is asking if I created like a game object master. I did. It's actually called Game Object Manager. I talked about it a little bit on a previous stream, but it's essentially just a class that manages spawning things into the world. It's pretty simple, but it's a singleton kind of pattern that anything can call to create objects on the fly. Because we're doing procedural generation, obviously, like everything is created dynamically. Yes. So, well, the way that I'm going to handle that, so Salmon Moose brings up a good point. He says that you probably want a game object list so you can assign toggleable items to specific buttons, and that is true, because otherwise all buttons toggle all components, and it doesn't make any sense. But what I want to do is I want to kind of give these things like an identifier. So, for example, in button, what we'll probably do is we'll say like public key, perhaps, it could be a string, key is equal to, whatever. It could be like A, for example. And then on the wall block, we can also give it a string key of A. And so we can change those on the fly. And the reason that I want to do it that way, I talked about a little bit about that in the early part of the stream, is that I want, because everything is procedurally generated, I don't want to have to like set these buttons up in the Unity editor, and I also don't want to have to have a lot of code that links the buttons up to the wall blocks at like level generation time. And so this is a little different way of doing it. It's a little like looser of a coupling between the objects, because basically what's going to happen is that anytime the button gets activated, it's going to go through and look for any wall blocks that it can toggle. And if those wall blocks have the same key as itself, then it will do that. And then that'll make my procedural generation job a little easier, because then I could just say, put an A wall block in this room and put an A button in this other room. And those two objects, I don't have to actually make them reference each other, is the point. Right, yeah. So Salmon Moose says, you don't have to, you can assign the links as you build the level, which is true. That's what I was doing before, but that requires a lot more complicated code. So I have this, originally this wall thing that I was working on, the button wall. You can call this link button, which essentially you pass it a button component, and then it will listen to the state change event of that button in order to know how to act. And that works perfectly fine. It's kind of I don't know exactly what to call it. I guess just a preference about how I want these pieces of things to communicate with each other. So I'm going to try this way and see if I like it, because I wasn't super happy with this, because essentially what happens with that is that you have these scenarios as you're generating the level where you have to make a pass at the end to link all the stuff up, or do all of the walls first and then the buttons and then link those things after they're generated. I wanted this all to kind of happen dynamically, and I want to be able to just throw stuff in there and have more of a loose coupling between these components. I might regret it later, but we'll see. This is what I'm going to try and see how I like it. That being said, let's continue with that. So the button itself, we want to, what was that function? It was object find objects of type. And then the type is the hinge joint. So let's just see if that works. So we'll say this will be wall block. We'll say blocks. Oh, this is going to be array. And then we'll say equals object dot find objects with type, or is it of type? Of type. Of type, and then we'll pass in type of wall block. Right. As hinge joint. Do I really need to say as an array if it's already that? We'll see. I might. Wall block, yeah. As wall block array. Salmon Moose says, you don't want to build walls without matching buttons, or buttons without matching walls. Yes, that is true. But the point is, I guess, that in my dungeon generation code, so the dungeon generation code kind of lives outside of the code that actually creates all the prefabs. And so what I can do is I can kind of say in the metadata, here's an ID, and then as I generate the individual components, I can just give them this ID, and I don't have to go look for the buttons that link them up. The other nice thing about it is that I could just say drop a new button or drop a new wall into the world dynamically, not at generation time, and it'll just find it automatically. So let's just say debug.log blocks.length and see if this will actually work. Because we have a button, right, and we have the button wall here. And so so yeah, there's one thing in the level, so that's good. So we're actually getting the thing that we want. And then here we can just say for each, this would be wall block in blocks, and then we can just say block.toggle, or we'll say deactivate, sorry. I think that's what we named it for now. And then, you know, here would be like to do something. To do activate instead if, you know, state is true or whatever. But for now, this is how it's going to work. I think maybe I'm not doing a great job of explaining why I want to do it this way, but I think I removed some of that code about the mechanisms, but I found it more tedious than I wanted it to be in code to actually link those things together and manage those dependencies. And so, again, this is kind of just an experiment to see if I like this this method better. So let's see. Hopefully it'll work so you guys can see some actual progress. To do, fill out this to do. Yeah, that's right. Yay, look at that, it works, awesome. So it goes down. So essentially, you know, the nice thing about this method is that I could, let's see if I can do this at runtime. Can I just like duplicate? Yeah, wall block 1, great. So I created another wall block at runtime, wherever it is. Why can't I move it? I guess I can't move it in runtime with the thing. I guess I can move it this way. There we go. Oh, hey, collided with the player. That was funny. Unexpected. But actually, since we have this trigger in place now, we can remove this collision hack that made it so it's activated right away. Anyway, so we got that, and we'll go to this wall block, and we'll duplicate it, and then we'll move its X over here. Oh, no, it collided with the other thing. What the heck? Oh, that's right. I shouldn't move it into the block because the block was it counted as the button triggering. Anyway, so we'll do that, and then we'll change the Y so it goes up. And then if we, you know, now those things go down together. So it's kind of a loose situation where basically all the button has to do is just be smart enough to say, hey, anything in the level with this particular component, I want to call a method on. And I think, you know, in the future, what I would do with this is actually have this be like more of a generic component, like toggleable or something, where it just has like a state, and then I would actually handle all of the wall block specific stuff, like over here in the other this other class. And then so that could be true for like it could be a block, it could be a door, it could be a who knows, it could be anything I really want it to be that's toggleable. Dan, have you not seen the lizard tongue? Yes, that was the lizard tongue. Oh. Woo! So this thing is pretty awesome. I like it's my homemade sound effects. We're gonna take a small detour here and put a sports ball on the level just for Dan's benefit. Whoop. So I can like pick things up and spit it out. There's also the grapple target, which we'll grab right here. Although I may have messed up the collision. Yes, I did. So let's see if that works. Oh. Yep, there he goes. So he can pull himself to grapple targets with his tongue, like a grappling hook. Anyways, we've seen that before, but got to show off the tongue for Dan, because it is one of my favorite parts of the game so far. Oh, thanks, Ray. Yeah, I used the tweening, the suggestion you had, I think, several weeks ago to make that look a lot nicer. You guys could let me know too if you think that the bot is a little too aggressive right now. Right now, I think it's on like 5 minutes of time plus 10 lines of chat. If both those things have been passed, both those thresholds, it'll spam some stuff. But if it gets annoying, I can always decrease that. I kind of just wanted to have some kind of automatic thing that would give people links to more info, should they be interested. So anyways, that's actually working pretty well. Now the other thing we can do is we can actually create a couple different versions of these things. Oops. So what we can do is we can duplicate this guy, and then we'll move him around. So we've got another block over here, and then we'll duplicate this guy, and we will change these things to B and B. And didn't work. Oh, right, because I haven't actually written the code that differentiates. So what we want to do here is we want to say if block.key is equal to key, then do it. Otherwise, go away. So now we'll get rid of that to do, because why not? Yeah. All right. So now it should work, because like Salmon Moose was saying, you know, we don't want one button to toggle everything. There we go. So great. So now the buttons control different blocks independently. But if we were to have, you know, several versions of a block with the same key, then they would all go down together. So like right here. So it should all be A's. Right? All right. Awesome. Hey. Looks like I don't know how to say that name. Plesiades. Thanks for joining. And let's see. The next thing we want to do is we want to make these things reactivatable, if that makes sense. So we want to say activate, and then, you know, active is equal to true, and actually might end up moving this collider logic somewhere else, because really the collider piece here is the only thing that makes this component not as generic as I would like, probably. So that'll be true. You know, when it comes back up, we want it to be collidable again, and then, you know, public delegate void wall block activate, and we'll basically just do the same thing here, but in reverse. And we'll call this on activate. And then, of course, we'll need to create another public event, wall block activate. Call it on activate. And I'm actually going to move this stuff in a more consistent order. On activate, great. And then here we can say wall block on activate plus equals on wall block activate. And then we'll just do this in reverse again. And we'll change this to active sprite and active sorting layer. And then we will set those up. So active, and this is going to be active sprite. And we'll go back in here and we'll get rid of some of these clones. Delete. And for this guy, so the active sorting layer is going to be tall objects. I wonder if you can actually use the, like if I could create a sorting layer thing like this. Like, is there a sorting layer property in Unity? Sorting layer, Unity. like a type. Ugh, no, I don't want a video. Maybe it's in sprite renderer. Signing layers. Well, who knows? I feel like there should be a way to do it. Like instead of saying string for these sorting layers, I could say layer or whatever. It's kind of what I want. I mean, just because then I could. That's really just a nicety thing, you know, because then in the editor here I could say I could pick from the dropdown instead of having to remember what the actual string name is. Yeah, Unity does have pretty good documentation. It's been a lot of help, and I mean that's another great benefit of choosing a platform that's so popular is that there's a lot of like Stack Overflow. The Unity Answer site is really great. There's so many people using it that a lot of these things you would run into are either documented by default or someone else has run into it and figured out how to do it. Anyways, so the other thing we want to do is we want to give it the active sprite, and even though it has a sprite by default, we want to be able to go back and forth. So it's going to use this one. Oops. So wall block, and then we're going to drag that guy here for the active sprite, which is wall block up. And then here, button wall and button. So instead of deactivate, we're going to say, if, is it just state? Yeah. If state is true, which means it's up, then we want to activate it, yes. So we'll say block dot activate. So AC Wraith, thanks for watching. Says rendered a sorting layer name, or sorry, Unity search can lead to a lot of outdated info. That is also true. I've run into that a few times myself. Yeah, Salmon Moose. I was actually looking for a way to not have to use the strings. Like, I want in the Unity editor, instead of having this be a string, I want to have this combo box right here where I can select the sorting layer. I don't know if that's possible. But yeah, it is pretty likely that things will change with any programming environment. Stuff on the internet stays around forever. There we go. So, well, the only bad thing is that it's reversed. Whoops. So we actually want to do that. There we go. We can get rid of this other button for now too because it's not doing anything for us. Great. So now, let's say that there was a bottleneck here. You can't move through. So now we're back to earlier where we had that working with the old method. But, like I said, I kind of wanted to figure out if this is something I like. What we can do is we can drop that ball on the thing, and there we go. Now we can pass through it. Give me that. Thank you. Awesome. So now that we have that stuff, we're going to go into our prefabs. Let's create a new folder called Gizmos. And then we're going to create the wall block. And let's see. Reset some of that stuff. Yep. So you can basically, the way this button works is that anything that collides with the button can trigger it. So anything that is, what I've called um, a solid entity can do that. You can also push stuff onto it. So, for example, we have like these barrels or boxes or tables or whatever. So we'll just grab a crate and dump it in there. So you could also just take this guy and like push it down here. Whoa. The friction on that needs to be turned up a little bit, but yeah, essentially. Your tongue cannot trigger the button right now. I mean, it could if I wanted it to. And I probably will have something like that. Whoops. I probably will have something like that. Oh no, it does right now. Never mind. I didn't want it to work that way right now. For this particular button, I think that in general, I do want to have that be the case for some things. Like there might be a switch or like a button on the wall or something. Like let's say there was a pit and you could only hit the button by using your tongue, then that would be a good use of that. If there were a button over a pit. But yeah, it's the fun world of Unity physics interactions where things work the way I don't think that they were going to. That's right, tongue shouldn't trigger those buttons. Or maybe it's fine, you still, in this particular case, it doesn't really change much about the interaction, right? Because you can still, you still can't, you still have to push something onto it, So it's not like you can really cheese it at the point. We're not going to ban you, Joe. Awful jokes are very welcome here. Let's see. Arprig Artura. I'm going to butcher that name. I'm very sorry. Another gizmo idea would be a wall block where you have to pull a rope and tie it to something to pull up the bucket to cross the hole. Yes. That sounds like a winner. So what I want to do now is I want to put this stuff in the level. So we got these buttons and we got these wall blocks, and now I want to actually generate them. So what I'm going to do is, where is my level builder? I haven't been in the procedural generator for a little bit, so I need to get my head back into that. So in the room populator, this is where a lot of the code gets rather complicated, because this is what actually puts together the room or the map based on rooms. And if you've tuned into the stream before, basically the way that this works is that we have a set of sprite tile rooms, resources, data, rooms, that kind of fit certain aspects. So like, this is like a corner room or a corner hallway. Dan Nagel correctly points out that Matt has been replaced with a very small script. So, basically what happens now is I just chain Matt to his tablet and make him draw stuff, and then all of the marketing is now done with the bot. So anyway, so this room, the map gets stitched together with these rooms, and then these this function is where the rooms actually get populated with stuff. So, for example, out of this XML file, which kind of dictates how a level gets generated and populated, in this specific instance, there are basically triggers or hints, as I like to call them, that tell the map generator where to put stuff. So in sprite tile, you can see that we have these basically these triggers, which are these kind of bluish purple areas with numbers in them. And I can use those triggers to put stuff in those locations. And so you can see right here, this is where actually the wall blocks would go onto these triggers that are based upon the direction. the exits of the room. So what we can do here, originally when I created this, I wanted a way to specify which direction that the blocks would be in. But for the purposes here, we're just going to put them on all of them, I think. And so what we're going to do is populators. So where's the populators? Add monsters, populator objects. So the other piece of this is the room populators, and for specific kinds of rooms, they have different things that would go in them. And so for the ending room, which is the one we're going to work on right now, there's a rug in it right now. And so if we were to go back into the actual game scene, where we have stuff, and then we'll cheat by showing our gizmos. Oops. Showing our gizmos, and then we'll actually zoom out a little bit. And this is our level, and so we can see that our end room is actually right here, and it's got the rug in it. But this is what the level looks like overall at this current moment. And so what I want to do right now is I want to put the wall blocks here in this kind of hallway. And so let's do that. And for now, I'm just going to do this. I'll say if, let's see, where am I grabbing the populator? Room.type. So room.type is equal to end. We're just going to hard code this for now just to make sure it works, and then later I will come back and make this less hard coded. But what we're going to do is we're going to add room objects to this room that we're currently in, which is the room variable, and then it's going to be this is actually an array of stuff, but in this case we're going to create a string. We're going to call this things, and it's going to be, I think the way this shorthand works is something like this. I can just say gizmos / wall block, and then I'll say things, and the trigger here is going to be 201, and then what's the last parameter? Oh, the density. Yeah, we want it to be 1 for sure. The density is actually a normal that specifies how, of all the available hints or triggers in a level, how many of those should be used. And the reason we're doing 4 lines of this is because there are 4 distinct triggers for each direction. Dan's asking, does AWL2 have the whole level loaded versus a room-by-room loading like Zelda 1, AWL1 style? And the answer is yes, it is a whole level at once. Which, we kind of feel is a little more interesting because it allows for a little bit of cross-pollination between the rooms, between maybe monsters or traps or things. And honestly, it just has a kind of a better feel to navigate. You don't have all these, like, transition screens that, kind of disrupt the gameplay a little bit or take the control away. Populator sounds like a weapon from Balloons. Sounds pretty nasty. You got populated. Pretty bad things. They probably don't want that to happen. I don't want to get populated, that's for sure. Great, so let's just see if that actually worked, because we didn't have any errors, so maybe it's fine. Yep, look at that. All right, we got these wall blocks like right where they're supposed to be. That is awesome. I love it when things just work. Turn off our gizmos. Whee! And we'll head to the side level where we can now not pass because there are wall blocks in the way. And so eventually this rug right here would get replaced with like a warp zone or something, right, that signifies the end of that level and ties it to the next level. which actually does work. I've just taken it out of the game for now because, you know, a lot of game development is like bulldozing and redoing certain things. A lot of the pieces are kind of in place for that stuff, but keep changing my mind about how I want it to actually work. But this is about the size of the generated levels right now. Last week I was actually talking about how I made the generator a little better with, you know, things like more hallways and smaller rooms. And so I think that actually goes a long way to helping the levels feel a little better. They're um, not so boxy, you know. You get these kind of areas where you have like these T-section hallways and stuff like that, which are a little bit more interesting to navigate. And as you can see, we have these great tiger hat paintings all over the house because, you know, who doesn't love tiger hats? So that was easy. And kind of to reference my earlier talk about the hooking up the gizmos, you know, see how easy it is to basically just dump these things into the level without having to really have this generator understand the relationship between the objects, right? Like I kind of want to keep the populators like really dumb, just because then it's easier to generate, and then it puts the responsibility on, you know, the button itself to actually do the lookup of what it needs to trigger, as opposed to me having to tell it during level generation time what to trigger. Yeah, thanks, Ray Guy. It does, you know, there's a little bit more variation, I think, in it, and it has a few things going for it. One is that there's just different stuff going on, which um, kind of feels different. You know, you get different experiences. You get enemies in smaller areas, enemies in larger areas, enemies in a hallway, and different things will be more or less dangerous in a closed space or not. The other thing is that it also kind of gives you a little bit better mental map of the level. You know, you can kind of, you know, feel like there are landmarks. You know, like, oh, you know, there's this big room with these pillars, and then it kind of goes into this four-way stop right here, and so you kind of know, okay, I'm in this room and I got to go backtrack, and I know that like if I go up, it's gonna be that room with two pillars, and you know, it's not just you know, it's random obviously, but it kind of gives you a little bit better idea of the relationship of things in the level. So like right there, we actually had like two four-way stops in a row, and then this kind of elbow corner room. Hey, welcome, first timer, BMI Quillen. Thanks for joining. Pleasure to have you. So yeah, anyways, yeah, the level generation is something that's constantly being iterated on. Something I was actually talking to Matt about today was how I want to kind of have these decorations kind of more targeted to the room. So like right now, the decorations are kind of just all over the place. So like in this room, for example, we have like a table and another table and a bookshelf and a crate and a ball and a plant and some statues and some lights and that kind of stuff, and an empty bookshelf. And I think what I want to do here is I want to keep the number of distinct decorations per room down a little bit. So for example, like you might come across a room that has mostly end tables and plants, and like that'll have a certain feel to it. The one thing that I learned from AWL 1 is that when you just throw everything together as a random mishmash in a room, the rooms really start to feel too samey, and the player doesn't really get a good sense of like the individual properties of perhaps the enemies, right? Let's see. Pedro Mundo says, are the colliders and the graphics for the walls separate entities or all together? They are separate, and that's actually something that Sprite Tile does. Sprite Tile is the tiling system that we're using here, but you can kind of see what it creates here. It creates these tile layers. So if I turn on gizmos, these sprites are actually just the sprites are actually only here. So if you're looking at this level from a kind of high level view, this is the level with all the game objects in it. You can see the slimes kind of moving around and stuff. The sprites themselves are actually just a kind of pool of sprites that get reused. So as the camera moves, these sprites get moved around and changed. Their sprite value actually gets changed. So if I now go back into the scene, you can see that the sprites that are the visual sprites are only the sprites that are in a certain proximity to the camera. And so that's why, like, when I'm in this scene view and I'm looking at the entire level, like, you're actually not going to see all the sprites that make up the terrain because it's more efficient to not have, like, this would be thousands of game objects probably. Yeah. And then so if you take a look here, there's actually a group for the colliders, and the colliders are really just they're really just game objects with polygon colliders. And so those things exist all the time, obviously, because they need to be there for all of the physics interactions for things that are off screen. But yes, they are separate. Let's see. Have you considered minor variation in the floor tiles depending on the room, carpet, etc.? Yes, that is something that we're working towards, having more variation in some of these things. Actually, Matt has done a good job of drawing some different environment tiles. So like here, there's actually like pieces of wall with kind of the break. There's pieces of wall with like a pillar or not. And then the wall tiles are probably going to be expanded such that there's a little bit more variation there too. We actually do have rugs too, so like there's a rug here. And depending on the environment, we'll probably create a little bit more variation there. But yeah, that's a good question. Let's see, a lot of questions left. Thanks for all the chat today, guys. It's awesome. It's good to see. Is the canvas size exactly the size of the camera? I don't really know exactly what you mean by canvas, but the way that sprite tile works is that sprite tile attaches to the main camera, and then it will show as many tiles as it needs to fill up the camera, if that makes sense. So if the camera was to zoom out, for example, like if I went to the camera and I changed the camera size to like 8 or 10, where you see more of the level, sprite tile is going to accommodate for that and, draw more tiles. And so obviously the more tiles you're drawing, the more game objects you're going to be rendering. And so the more you zoom out, the worse your performance is probably going to get. But all that stuff's kind of handled automatically with sprite tile, and that's one of the reasons that I like it, is that it kind of removes the need for me to care about those kinds of problems. Let's see. Nice. Yeah, the part's not the gray background. Yeah. Let's see. Cool. Well, I'm glad that that can answer some questions. So anyways, we'll get back to the system at hand, or the task at hand, which is to put the button in here. Like we were talking about earlier, we have the, here's our exit, which actually has the rug in it right now, or what will be the exit, and then got the colliders right here in the doorway. And so what we want to do is we want to put the button in a certain place. And so what we're going to do actually is there's another room right here called the challenge room, and the challenge room actually has the plant in it. And really, that was just for me to test out the room populating code to make sure that it was doing what I wanted it to do. But you can see the challenge room always comes right before the exit. And so in this case, there could be a boss there or something to kind of give you like a final battle, or it doesn't have to be a boss. It could just be a regular room as well. But what we're going to do here is, instead of putting the houseplant in there, we're actually just going to drop one of the pressure plates in there. So objects, pressure plate, and this should just be really quick and easy because these systems already work. And obviously, like, we would not want to have the location of this thing be right next to the wall, but just for testing purposes to make sure this is going to work, that's what we're going to do for now. So let's see, where was this in relationship to me? So I've got to go over and up one. So I'm going to run over here, and there's the thing, the button, turn off gizmos, and oh, I know I did wrong. I neglected to update. Oh, it looks like Dan Nagel's leaving. Thanks for showing up, Dan. Really appreciate it. Thanks for coming by. Glad you enjoyed it. The pressure plate, actually, we need to change the collision group to be something that will actually collide with the player because it wasn't. So we'll show these things again, and we're going to need to go down and to the right. So we'll head down there. There. Now we can collide with that thing, and obviously, when it comes back up, the walls come back up. So what we're going to do is we're going to try and move this guy up here and get him to, oops, and there we go. Now we can walk through this doorway, and we can warp out to the next level, or not. We can just actually hang out on the rug because the interesting thing about this, there was another stream actually where I had some slimes running around this room, and the slimes were colliding with these buttons, and they could theoretically trap you in this room because if you were in here and a slime collided with the button, then the walls would go back up, and then you would be stuck. So let's see. Pedro says, since we're having question time, what about collision and interaction with props? How is that done? Pretty easily, actually. The more I work with Unity, the more I'm trying to lean on the rigid body physics interactions. And it's all really simple stuff. So, for example, like these props right here, like the barrels, they're really just a sprite renderer with a box collider attached, and then a rigid body 2D, and then the rigid body, and then the layer is like I have this solid layer for things that I would consider to be solid in the world. So things that would collide against each other, things that the player would collide against, things that projectiles would block projectiles, things like that. And at that point, the player is also a rigid body, and he has velocity and stuff. And so once you kind of hook those two things up, Unity really does the rest in terms of just the basic movement. So like these tables are really just box colliders with rigid bodies that the player can interact with, right? And so it's kind of fun because it has all kinds of physics implications. Like if I take this ball, I can shoot it at stuff and it'll move around, and it'll bounce off all those things. And that's a lot of that stuff that Unity just does for free. Oh, I got stuck. Oops. So yeah. And really all you need to do if you want to do anything else, like for example the explosive stuff, if you want to have any other extra interactions, you can just hook the collision enter, like on collision enter. And so here we have like the code that handles like the explosive crates, and when it detects a collision, it just says if the velocity of the collision was greater than such and such a value, then I'm going to explode. And so that's how we get that effect where, let's see if I can find any in this particular instance of the game. See if there are some. There's some crates. And I don't see it right now. Shield generation stuff is going through a lot of iteration right now, so I don't always get the stuff that I want. I could go back to seeding it again, which I might do for this stuff because it's a lot easier. But anyways, the point of it is that the physics interactions are largely controlled by Unity's rigid body and box colliders. So yes, yeah. So for the props, the sprite renderer and the box collider and the rigid body are all in the same entity. The only thing that's separate is the map, and the reason that it's separate is because it's just way more performant to only have these sprites that render the background, you know, just in the area of the camera. Yeah. So yeah, I think we're going to kind of wind down. Actually, hit the about hour-and-a-half mark with that completed puzzle. Also, thank you, Joe, for the congrats, because I do love it when stuff actually works. It makes me feel good. But yeah, I'll hang around for another couple minutes, and if anybody has any particular questions about this stream or Unity in general or Wizards Lizard 2, let me know. I will also take the opportunity to plug our various social presences. You can always follow us on Twitter at Lost Decade Games. You can come join our excellent Lost Decade Games community, forum.lostdecadegames.com. Come and chat with us, post stuff about game dev, etc., etc. Oh, great question. Joe says, I have a question. What resolution will the finished game be? Native res. That is a good question. We're going to try and support several resolutions because one of the things that became apparent to us with a Wizards Lizard 1 was that it was really important for people to be able to change the resolution, and also it was important to not have black bars. And because streaming is like such a big thing these days, and a lot of people are, you know, following these streamers, looking for game recommendations, looking for things to play, we want to make sure that the resolutions and the aspect ratio of the game are as best supported as we can make it. So to that end, right now I think that we're going to target 1920 by 1080, which we've determined is the most popular resolution on Steam. And it also is kind of a standard resolution of, like, you know, for example, the monitor I'm using right now. Right now, the assets are actually targeted at 1280 by 720, but this is actually a conversation that Matt and I were having just this morning about which resolutions to target and how to do that. But the bottom line is that we want to support as many widescreen resolutions as we possibly can, and actually Unity does a lot of that for you with the scaling and stuff. And really, the big piece for us is figuring out how to make sure that, like, our assets scale appropriately with the different resolutions. Total Biscuit will approve. Well, then we're golden, right? Then he'll play Wizards Lizard 2, and we'll sell 11 billion copies of the game. I guess Joe is stalking us. It's kind of scary. We should invite Joe into our design meetings. That'll be a lot of fun. Yeah. So, anyways, that is about the stream for today. If you guys are interested in a Wizards Lizard 2, you can sign up for our mailing list, which you can get to by going to wizardslizard.com/2 and sign up to our mailing list, and you will get all of the details whenever something new and interesting happens. We're actually going to have some announcement very soon regarding the next steps for the game, so look for that. And you know, we'll be doing this again next week, Monday, 6 p.m. Pacific, same time, same place. And you can also check out this video and the previous episodes on YouTube. I usually export them within a day or so. And again, thanks for showing up. I really appreciate all the great comments. Hopefully I'm not too all over the map with trying to answer questions and get some of this work done. So hopefully it's useful for everybody. It's certainly a lot of fun for me. So thanks for coming. Oh, look at that. The Moobot doing Matt's job for him. Time of day is great, by the way. Great. Well, I'm glad. We were doing the morning stream earlier, and that didn't seem to work for a lot of people. So we made the decision to try later evening stuff. So definitely getting uh, a lot more interaction on the later stream, which is good. So, anyways, I'm gonna sign off. Thanks everybody for stopping by, and have a great rest of the week. Ship it.